So let's see, next function in the library of functions is called the absolute value function. The standard form of absolute value function is f of x equals absolute value of x. Okay. So still 3 sub-questions. Determine whether absolute value function is even, odd, or neither. State whether the graph of function is symmetric with respect to the y-axis or symmetric with respect to the origin or neither. All right, so let's look at first A, all right? So in order to determine function is even or odd, we need to evaluate f of negative x, right? So replace x by negative x. So absolute value of negative x is the same as absolute value of x. Okay, negative sign, right, after the absolute value is eliminated. So therefore, that's the same as original function f of x. So f of negative x equals f of x. Does tell us, right, based on the definition, this is an even function, right? So if it's an even function, and a graph must be symmetric with respect to what? With respect to the y-axis, right? So that means if we can get half of the graph, and then we can base on the symmetry property to get the other half, right? Okay, now let's look at the B. Determine the intercept, if any, of the graph of f of x equals absolute value of x. So let's let x to be 0. So f of 0, that equals absolute value of 0, which is still 0. Okay, so x-intercept is 0, 0. Okay, y-intercept, this is a y-intercept. Let x be 0. X-intercept, let y equals 0. So that means 0 equals absolute value of x, which is derived x must also equal 0, right? So both x and y intercept is at origin 0, 0. And then part C, we want to graph the function, absolute value function, right? We want to graph it. Okay, so in order to graph the function, we need a few points, right? X, f of x. So if we only get a half, right? We get a positive one, and then the other half we can, based on symmetry property we talked about earlier. So let x be 0. We already know is absolute value of 0 is 0. 1, absolute value of 1 is 1. 2, absolute value of 2 is still 2, right? 3, 3, and so on. All right. So where I can graph, okay, let me try over here. So set up rectangular coordinate system, okay. And then y coordinates 1, 2, 3, 4. So 1, 1, right? That's one of the points. 0, 0, of course. 1, 1, and then 2, 2, and then 3, 3, and then 4, 4, right? So we can get, and then it goes forever. So that's why the arrow is means it goes to infinity. And then graph symmetric with respect to the y-axis. So just flip of the y, and then we can easily see, right? That's the absolute value function's graph. It's like a V-shaped, okay? It's the V-shaped. You can remember, okay? Absolute value function's graph is a V. All right, this is a more accurate graph. And then if we summarize the overall property for absolute value function. Domain, it doesn't have a roots, right? Even index roots, it doesn't have denominator, so there's no any restriction. That's why the domain is all real numbers. But the range is not all real number, right? If you look at a graph, see the graph will never be below x-axis, right? So is from 0 to positive infinity. Okay, so the range is non-negative numbers. And x-intercept and y-intercept both at origin 0, 0. Okay. Function is an even function. Graph symmetric with respect to the y-axis. And then increasing, decreasing. Okay, let's go back to the graph, okay? From negative infinity to 0, function decreasing, right? From 0 to positive infinity, function increasing. Okay, that's the part we can see from the graph. Okay, so decreasing on the interval from negative infinity to 0, increasing on the interval 0 to positive infinity. And it has an absolute minimum. The absolute minimum value is 0. It occurs when x equals 0, right? So next function in the function library is called a constant function. We see this function before, right? Constant function, which is the horizontal line. The standard form of constant function write as f of x equals b, where b is any real number. Well, actually b is the y-intercept, right? We learned this before. B is the y-intercept. So constant function means doesn't matter x value equals what, the y, okay, f of y always equals to the same constant. So that's why we call it constant function. So the graph, constant function's graph is a horizontal line. So you need to remember this actually is a theorem. Remember, f of x or y equals b. That's the horizontal line equation. Next function we want to introduce in the function library is called the identity function. Identity function standard form is f of x equals x, or in other words, y equals x. Okay, that's why it's called identity function. X coordinates, y coordinates, they have identity values. Okay, so this is a linear equation, right? Linear function. And a graph, linear function, the graph is a straight line. And an identity function, every point, x, y coordinates, they have identical values. Okay, that's why the line is like a 45 degree, okay, cut into half, right? This is a 45 degree, this is a 45 degree. The overall, there's a 90 degree right angle, right? So that's identity functions graph. So absolute value function, actually the first quadrant is the part of the identity function, and then this part, because absolute value, so that's why flip, okay, to the top. Okay, so you can connect the absolute value function and identity function. Okay, can connect these two together because they have similarities, right? Half of the graph is the same. And then square function, we learned quadratic function. So square function, it only have a quadratic term, okay? Only have x second power term, and the leading coefficient is 1. So it doesn't have bx plus c part, okay? So all the quadratic function, the graph is a parabola, right? And then square function is a special quadratic function. So its vertex is right at origin 0, 0. All right. And a parabola open up. And then if you trying to find it's even or odd, you can evaluate f of negative x. That equals negative x squared, which is equals x squared, right? Negative sign after raised to the second power is eliminated. So we got the same as original function f of x. So that's even function, right? So parabola have symmetry property. Remember we talked about that in quadratic function section. So graph symmetric with respect to the y-axis, okay, because it's an even function. And increasing, decreasing, from negative infinity to 0, function decreasing, from 0 to positive infinity, function increasing, and then it has a local minimum, right? Here is the turning point. It has a local minimum, and then the minimum value is 0. It occurs when x equal to 0. This is also an absolute minimum. Sorry, no absolute maximum because this is an open interval. Domain are real numbers. The range is non-negative number, right? You see the graph is never below x-axis. And then the cube function, very similar as cubic function. Remember cubic function, what it look like? It look like this, right? It's just a curve is different. This is third root function, cube root function. Cube root function, the curve is more towards the x-axis, but the cubic function is the curve is towards to the y, close to the y. That's the only difference. Other property, okay, cubic function is all the same as cube root function. Square root function we already talked about earlier, okay, that's also a key function in function library. This is the third root function. And the last one in the function library is called a reciprocal function. Domain of the reciprocal function standard form is f of x equals 1 over x, right? And then domain, since it has a denominator, so domain is x cannot be 0. Okay, range is the same. Y cannot equal 0. So that's why you see this both end, okay, approach x-axis, okay, this end approach x-axis, this end approach x-axis, but will never touch x-axis. And then this part 2, approach the y-axis, approach y-axis, but will never touch y. So later in the pre-calculus class, if you ever need to take that, you will learn more, okay, about the asymptote. So actually, x-axis, y-axis, these two axes, they are horizontal and vertical asymptote for the reciprocal function. And then if we pick up a few key points, and then we can briefly graph it, okay? So just remember reciprocal function have two parts. One part in first quadrant, the other part in the third quadrant. And this function is an odd function, right? Why? We can test it. F of negative x equals 1 over negative x, right? Replace x by negative x. And then we can write as negative 1 times 1 over x, which is negative of f of x. So f of negative x equals negative of f of x. That's why function is odd function. Therefore, the graph symmetric with respect to the origin. Okay, so you can see every point, okay, symmetrical point. If you connect the 2 points, they must go through the origin 0, 0, and they must have the same distance, okay, from the origin to this point, and the origin to this point, they have the same distance. Okay, and the same as the other one, if this is the one, okay, and then this one will be symmetrical with respect to here. This is a symmetrical point. All right, that's absolute value function.